today's session on some important derivations from electromagnetic field theory. Today I will discuss some important derivations which is the comprises of all the parts of the electromagnetic field. So first today we will discuss about the cylindrical to Cartesian coordinate. So what is the Cartesian coordinate? The normal x, y, z is known as the Cartesian coordinate, and in the case if we are thinking about a cylinder, this is known as the cylindrical component, and the cylindrical component, as we know, the main component is rho, phi and z. Rho is the radius, rho is the radius, phi is the angle, and what is z? Z is nothing but the height. So you can see here this figure shows one cylindrical coil is there whose height is z, and this has the radius is rho, and rho z phi. So we can write from here, what we can write from here? We can write from here that the z in the xy axis, if we compare it with an xyz axis, here also you can see this is our x-axis, this is our y-axis, and this is our z-axis. So we can think that the both z-axis are parallel. So both z-axis are parallel means, what is the both z-axis are parallel means? Both axes are parallel means z is equal to z in the xyz axis is equal to z. And what is the rho? Now you can think this is a circle, and here we can get this rho is parallel to this circle. This is our rho. This is our rho, radius from center to the perimeter. So this is rho. So rho we can divide into the two components, rho cos phi, and it is the rho sin phi. So we can write x is equal to rho cos phi and y is equal to rho sin phi. So here we got the Cartesian coordinate, cylindrical to Cartesian coordinate. If we know the rho, if we know the phi, we can calculate x is equal to rho cos phi and y is equal to rho sin phi. Similarly, we can also write, if we take the square, x square plus y square. What is x square plus y square? Rho square sin square cos square phi, rho square cos square phi plus rho square sin square phi is equal to rho square. So what is rho? Rho is equal to root of x square plus y square. Again z is same for both the case. And what is phi? Phi is equal to, if we divide the y by x, what we got? If we divide the y by x, so we got the sin phi divided by cos phi is nothing but the rho sin phi by rho cos phi is equal to tan phi. So what is phi? Phi is equal to tan inverse y by x. So we can see from here, if we know the x, y and z, we can also convert it into the Cartesian coordinate. And what is the Cartesian coordinate? Z is equal to z, x is equal to rho cos. So what is this? This is, we can tell as the cylindrical to Cartesian, or we can also, the another name of the Cartesian is the rectangular. What is this? This is the Cartesian to cylindrical. Now we will discuss the next question. What is this? Similarly, if we want to, another coordinate system or orthogonal coordinate system is the spherical to Cartesian coordinate system. What is the spherical to Cartesian coordinate system? In the spherical coordinate system, the main are the r, theta, phi. What is r? R is, here you can see r is nothing but the radius. R is capital R or small r is nothing but the radius. What is theta? Theta is due to the height, the half circle height. And what is the phi? Phi is the circular. The phi is the circular angle. So we can also compare it. This is the z. Now again we are comparing with x, y, z. So as I told, theta is nothing but the angle with the z-axis. If this is a z-axis, if this is our z-axis, we can write this is the theta, this is the r. So this angle is theta. So what is z? Z is nothing but the r sine theta. So what is the value of the, if this is the z, so we will get the another perpendicular axis. We will get the another perpendicular axis from here to here. So what is the value of the perpendicular axis? If this is z is equal to r sine theta, sorry, z is equal to, I wrote one small mistake, r is equal to r cos theta. So we got here this is equal to z or r sine theta. Now if we can divide the r sine theta into two parts. What is this? So if this angle is phi, if this line is r sine theta, so what is x? X is equal to r sine theta cos phi, and y is the sine angle, so it is r sine theta sine phi. So what we got? We got z is equal to r cos theta, x is equal to r sine theta cos phi, and y is equal to r cos theta sine phi. So this is a combination of the z, x, y. Now this is the, what is this? This is nothing but the spherical to Cartesian or rectangular. So if we know the value of r theta phi, we can easily calculate the value of the z, x, y. Now if we are doing the value of the Cartesian to spherical. So if we want to do the Cartesian to spherical, how we can get? If we add the x square plus y square plus z square, what value we will get? We will get r square cos square theta plus r square sin square theta cos square phi plus r square sin square theta sin square phi. So if we add this, we will get, what we will get here? If we take the r square fixed cos square theta, again if we take the sin square theta fixed cos square phi plus sin square phi is equal to 1. So we are getting r square. So what is r? R is nothing but the square root of x square plus y square plus z square. We got r is equal to x square plus y square plus z square. Second one, if we divide the y by x, what we will get? Cos phi will cancel out. Sorry, this is sin theta. So sin theta will cancel out. So what we will get? Cos phi by sin phi. Cos phi by sin phi is nothing but the tan phi. So what is phi? Phi is equal to tan inverse y by x. Now if we think about this angle, this is the theta angle. So how to get the theta angle? You can see this is our theta angle. If we take it, this is our r. So what is this? Cos theta, we can write cos theta is equal to base by z by base. So what is the z, and what is r? R is equal to x square plus y square plus z square. So what is theta? Theta is equal to cos inverse r root of x square plus y square plus z square. So like this we can prove the spherical coordinate to the Cartesian coordinate and Cartesian coordinate to spherical coordinate. Next we will discuss about the intensity of an infinite line of charge. So what is the meaning of infinite line of charge? You can think that consider an infinite line of charge of the rho L coulomb per meter square. What is this? This is nothing but the line charge density dq by dl. So what is line charge density? Line charge density is nothing but the dq by dl coulomb per meter along the z axis. And as this is the infinite line of charge means we are taking as minus infinity to plus infinity. Consider the Gaussian surface as a right angular cylinder of this. This is in the z axis. The length is minus infinity to plus infinity, and the radius is r. This radius is orange color is the radius, and radius is r. And we are assuming this is a line charge. Line is the diameter is very, very small. So we can write r is almost equals to 0. The length is L, and the flux density at any point of surface is directed radially outward. If we are thinking it is going radially outward in the AR direction, and it is again this is an example of the cylindrical coordinate system. We have three things: z, height, r, radius, and the angle phi. So if we write this, this is the equation. So what is the, according to the Gauss law, the electric lines of flux psi is equal to Q enclosed. U is the electric charge. So according to the Gauss law, we can write that the line of flux psi is equal to Q enclosed. So we can think that the line of charges is coming out from the total electric lines of force. So Q is equal to integration of d by ds for the top, integration of the d by ds of the side surface, and d by ds of the bottom surface. And as I told in the previous slide, r is almost equals to 0, not 0, but r equals to almost equals to 0. So d dot ds top by d dot ds bottom, is equal to 0. It is very much small. So what we are getting? D dot ds of the side, d dot ds of the sides. And what is this? So what is the equation? dr r d phi by dz. We know that the surface area of a for a, what I will tell, cylinder is always r d phi by dz. So we can integrate it. 0 to 2 pi is equal to 0 to L. So 2 pi r dr, you can write d also. We are using the dr because it is the radially it is going. So we got Q is equal to 2 pi r dr L. So if Q is equal to 2 pi r dr L, so we can write what is the value of the dr. So dr or d is equal to Q by, again Q is equal to d by ds. So Q by 2 pi r into L. Q by 2 pi r into L. L is the length. So if the value of the d we are getting here, Q by 2. So what is field intensity E? Field intensity E is equal to d by epsilon. So we can write Q by 2 pi epsilon r into L. So this is the intensity of a long line. So Q by 2 pi epsilon r into L. Now similarly, if we are thinking about the intensity of an infinite sheet of charge, means there is an infinite sheet of charge, means it is very big. So the flux will come out, again side, again down. But infinite sheet means the length is almost infinite. So this is equals to 0 because we don't know the side infinite sheet. This is the word sheet of charge, means the thickness is 0. So we can assume that, so we can write here, flux is coming from the top side, from the bottom side, and from the side and from the side. Because if it is like this, so if this is a sheet, so one is the top, one is the bottom, one is this side, another one is this side. But as this is an infinite length, we can assume that this is very big. So we can write that sides are always 0. Sides are always 0 and this is the infinite long. So what we will get here? We will get the flux is coming from the top and the bottom. Flux is coming from the top and the bottom surface. So flux is coming means Q is equal to integration of d top means dx by dy plus d dot dx by dy. So both are same, top and bottom is same. So we can write Q is equal to 2 dx dy. So what is Q? Q is equal to 2 d dx dy is x into y or 2 d into a. So what is the d? D is equal to, we got Q by 2a. Again charge per unit length. Charge per unit length, unit area is known as the rho s. Rho s is equal to surface charge density. What is rho s? Rho s is nothing but the surface charge density. What is the meaning of surface charge density? Q by a coulomb per meter square. So if we put the value, we will get D is equal to, what is D? D is equal to rho s by 2. Now, then what is the field intensity? Because our main aim to calculate the intensity is equal to rho s by 2 by epsilon. So we got the value of intensity. Next what we will get here? Intensity of an coaxial cable. What is the meaning of the coaxial cable? Consider two coaxial cylinders, means same axis, are forming a coaxial cable. So if this is an axis, another one is like this, and this is an example of an coaxial cable. It has two radius. What are the radius? The radius is, one is A, another radius is B. The inner conductor radius we are taking as A and the outer conductor we are taking as B. This is the length L. The length of the cable we have taken as the L. Again, this is a surface, because coaxial cable, it is little width is there, so we cannot take the charge about the rho L. The charge distribution on outer surface, and we know the general tendency of the charge is to stay on the outer surface. So outer surface of the inner cylinder is the rho s coulomb per meter. The surface charge density is rho s coulomb per meter square. The total surface area of the outer surface of the inner conductor, what is the rho s? Rho s is equal to, what is rho s? Rho s is equal to Q by area. And what is the area? 2 pi r. 2 pi r into L. So we can write it 2 pi A into L. So what is D? From the previous section we got that the D is, for a long conductor, it is D is equal to rho L by 2 pi r A L. Or we can also write D is equal to rho S. What is the relation? The relation rho L, again rho L is equal to rho L into L is equal to Q is equal to rho S into A. So we can write in the place of the, or here it is rho S into A. So what is the rho L? Rho L is equal to rho S A by L. So or rho s A by R. If this distance is R, we can write it rho s A by R. So we can write here rho s D is equal to rho s A by R by 2 pi R. So we can write Q inner is equal to rho s 2 pi AL. Q outer is equal to rho s 2 pi BL. So what is the rho s? Rho s is equal to A by B into rho s inner. If I divide these two, we will get rho s for the inner. Now we will do the potential calculation of the coaxial cable. So in the coaxial cable, as we discussed earlier, D is equal to rho L 2 pi r AR. So rho L is equal to surface area by length. So 2 pi AL for and 2 pi AL for the cylinder surface area. In the previous section also we got the same data. Rho L is equal to 2 pi AL. So AL will cancel out. So it is coming rho S into 2 pi A. So what is E? E is equal to rho L by 2 pi epsilon R AR, or we can write rho S 2 pi A by epsilon. What is potential? Potential is equal to V minus E by dr is equal to, we can write rho L by 2 pi epsilon R into dr. Now integration, according to the definition of the integration of a potential, the work done to bring one unit charge from the further point to the near point. So here the further point is the green one is B and red one is the A. So it is B to A. Or we can write it A to B rho L is constant, rho L 2 pi epsilon 1 by R dr. So is equal to rho L by 2 pi epsilon 1 by R. What is the meaning of 1 by R? ln R. A to B. ln B minus ln A. Rho L by 2 pi epsilon ln B by A. Rho L by 2 pi epsilon ln B minus ln A. Or we can write like this also. ln B minus ln A is equal to ln B by A. So this is the potential of an coaxial cable. Now we will discuss about the potential of a sphere. So this is a sphere whose radius is given as r. So we can write the potential calculation again. V is equal to E dr. So we are taking the two radius B to A. One is the outer radius of the sphere, another outer radius we are taking as B, and inner radius we are expecting as A. What is E for a sphere? Q by 4 pi epsilon r square into dr. So what is this? dV. So what is B? B is equal to again minus B to A Q by 4 pi epsilon r square dr. So what is the value? The value is minus, if we remove Q by 4 pi r square 1 by r square dr. So Q by, and it is, if we are taking the minus B to A, will be A to B. So Q by 4 pi into 2 and B to A, and it is minus 2, so minus will be gone. So it is Q by 4 pi into 2 into 1 by R integration B to A. 2 cancel out, so it coming Q by 2 pi 1 by A minus 1 by B. So this is the potential of a sphere. Determine the expression for the electric field intensity and work done on the point charge. We have to calculate the expression for the electric field intensity and the work done for a point charge. So what is the meaning of the work done? Work done means the force into displacement. So what is the work done? to bring one unit charge from infinity to another point is known as the electric field intensity. Is to call the work done. So force is equal to, we know, force per unit charge is basically nothing but the E. So in the place of force we can write Q into E dot S. So Q into E dot S. What is S? S means the displacement to bring one unit charge from one point to another point. And what is the unit? Unit is the joule. Next, calculate the Laplace equation in the point form. So from the point form of the Gauss law, we got rho is equal to rho v. Rho is equal to rho v. What is rho v? Rho v is nothing but the volume charge density. What is rho v? Rho v is nothing but the volume charge density. But we know that the D is equal to epsilon into E. So what is the value of the grad dot D? Grad dot D is nothing but the, grad dot E is nothing but the rho V by epsilon. Now what is E? E is, according to the definition, E is the grad of V. What is E? E is nothing but the grad of V. So grad of D we can write as grad of epsilon into E is equal to grad of epsilon is equal to minus grad V. And this is nothing but the rho V. This is nothing but the rho V. So grad square V is equal to rho V minus epsilon, and this is the Poisson's equation. This is the Poisson's equation. Now for the free space, the charge density formed in the free space. Charge density is equal to 0. So rho v is equal to 0, and we write the grad square v equals to 0, and this is the Laplace equation in the potential field. Extract the expression for the torque on an electric dipole in an electric field. So we will discuss about this. We have an electric field E. It has two charge plus Q and minus Q, and it has created an angle theta in between these two. So we can write the angle is plus Q and minus Q. So the force experienced by the plus Q, we can write it as the F1 is equal to E into Q. What is the force experienced by the minus Q? F2 is equal to minus E into Q. So what will be the total force? Total force is equal to F1 plus F2 is equal to EQ minus of EQ, and we can write force is equal to 0. Now if we have one, now when it is 0, but due to the plus Q and minus Q, the general tendency of the both charge has to come in the neutral condition. This is a general tendency of the charge. So there it will feel some torque. This according to the middle line, according to the point of the equilibrium, it will starts to rotate. So it will feel some torque. So what is the torque? The torque is nothing but the magnitude of the F is equal to perpendicular distance between the, what is torque? The perpendicular distance. So what is the perpendicular distance? Q. What is the magnitude of the force? In the previous slide we got that the force is nothing but the E into Q. E dot Q, and the what is the perpendicular distance? If this distance is R, so the total distance will be 2 into R. And if this angle is theta, then what is the value of this length? This is 2R sin theta. So what is torque? Torque is nothing but the EQ 2R sin theta. Again we can write E Q into 2R sin theta. If there is one charge Q, another charge is minus q, and they are at a distance 2r between them. What will happen? It will feel some force, and this is known as the dipole moment. What is the dipole moment actually? The magnitude and the distance between them. So q by r is nothing but the q by 2r is nothing but the dipole moment. So we got the value p into E sine theta. What we got here? Torque is equal to P into E sine theta. So today I have discussed some important derivations from the electrostatics fields, which are very much important for the exams and competitive exams. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.